Today I'll be talking about the impacts of fire and logging on small mammal populations. Ecosystems comprise of a complex mosaic of niches that support various aggregations of fauna. Small-bodied mammals such as the eastern chestnut mouse and the yellow-footed antechinus contribute to ecosystems functioning by providing food web stability, links between herbivores and high-order predators. Populations such as these can be affected by habitat fragmentation and vegetation succession as a result of logging and fires. The loss of habitat due to logging affects most, if not all, animals within the logged area and the adjacent buffer zones. Losses include habitat, refuge, direct food, and indirect food resources. Fires stimulate vegetation succession, creating dynamic changes in the landscape, shifting niches and driving change among population dynamics. The aim of this report is to determine if the logging and fire burn-offs have impacted the abundance and overall variation of small mammals present in woodlands in the Murphy Creek area, southeast Queensland. The study site located in the Murphys Creek region was divided into 6 individual properties consisting of 3 privately owned and 3 commercially owned. The 6 sites were divided, so 3 of the groups conducted trapping at 3 sites in the first week, and the remaining 3 groups of students trapping at the last 3 sites for the following week. At each site, 8 lines of 10 Elliott traps were set up, spaced 15 metres apart. Each line was kept at least 200 metres apart, and traps were checked, baited and reset each morning for 3 consecutive days. Here is an image of Ergon West showing an example of the trapping lines. Any animals that were captured in the Elliott traps were then processed and ear-notched to identify for subsequent possible catches. The raw data was aggregated and examined by a general linear models analysis with year, site, fire and logging as factors. Over the 3 years, a total of 53 small mammals were caught across the 6 sites. No significant catch rate difference was found between years or sites after the analysis of variance. However, the low R-squared value of 56.2 indicates that this model was of poor fit, as seen in Table 1. The burn severity analysis did not find any significant factors as well, although this model was a better fit to the data with the R-square value of 79.8, as seen in Table 2. The logging data upon analysis was found to have significant values across both year and site, with p-values of 0.0005 and 0.012 respectively. The standardized captures at the log site was higher than the unlogged site, with the fitted means of the log sites being 4.14 and the unlogged sites being 2.47, as seen here. The findings of this study showed that more animals were found in the log sites compared to the unlogged sites. This could be attributed to the increase in habitat complexity associated with fallen debris from the logging. The results demonstrate some impacts from both fire and logging on the abundance and variation of small mammals that are present in a location. However, the results from this study have shown that more small mammals were present in both the logged sites and the severely burned sites, which is in contrast to prevailing hypotheses. Due to the short duration of this study, I recommend future surveys having an extended trapping period to maximise the catch rate.